All right, what's going on, y'all? It's Dom here with Still Not CNC, and today we have to mess with the auto tool changer spindle and replace this connector here. The reason why is because I bought the recommended cable for the spindle according to the book, which one of the copper is 6 millimeters in diameter, and unfortunately, this connector that it came with, you can't even do that. It's for like 2.5 millimeters across. So I went ahead and bought a whole set. So here's the new one. You can definitely see that's a 6 to 8, I believe it said online. The housing and the adapter part. So this will be attached to the motor, and this will be the connector part that connects to the cable. So anyways, let's get to it. All right, so first off, we got to take this connector off here. So the way we do that is we just take our hot iron, put a little bit of flux on it, that way it's easier for these to come off. That's one. Two. Put some more flux on it, clean it off the tip. So if you have issues desoldering, just put some more solder on. And then the flux from the solder will heat up the element here. 3. All right. So according to this online one that it is supposed to match here. Supposed to. We'll see. If not, then I guess I'll have to stick with this other one. So right now I'm just going to stick these in here to see. Because if not, I could take this over to the lathe and make this a little bit smaller. It looks like it's just shy of going in there. So I'm going to take it to the lathe and grind this down a little bit. Just a little bit. Also looks like there's a plastic retaining ring in there too. So that way it doesn't short out. Anyways, I'll be right back. All right, so unfortunately the block that came from the automatic tool changer motor did not fit this female plug here, or this panel mount plug, whatever you want to call it. So what we're going to do now is just pretty much put it onto the machine here, and we're just going to widen out this hole a little bit. The spacing should be the same still. So what I'm going to do now is just put it in here, tighten her down. So I'm going to put a 6 millimeter in. It's a 6 to 5 or 5 to 6. Just want to make sure that the light is moving because I bent the needle before, so. Or 76, somewhere around there. So now it's time to zero the tool, and I just have a crude method of doing this. We can start. Yeah, these aluminum plates ain't that good for something like this when there's no stability on it. That's why I jumped. It's probably gonna do it again. Hopefully it doesn't pull it out of the socket here. All right, so off camera, I got it to finish up here. So that is done now. It's time to solder these points into the machine. Just gonna put this back on, try to match it up to its original. I don't think we could use this one to protect the insides, but we will put something on. So for now, I'm just gonna put these screws back in. Or a screw back in. All right, so. Just like that. Go ahead and heat that up. And that's how pretty much I did it to this one right here. Well, I didn't stick to this one, I could see it, but I guess because it was pushed down, look at that, that just fell right off. But we can give it like a little push on this to see if it even held to the case. No, not really, but it's touching. This one should be fine. I think this one can cover. Maybe barely, but can still cover. Yeah, that one's good. Oh, ouch. This one should be well more than enough. All right, let's get the show on the road. First one is down here. That one right there. I want to say pin 2 was yellow. Just one over here. want to push all these down as far as possible. Definitely don't want these coming in contact with this. So how they had this in here was like they kept turning and turning and putting it in like that. So we're gonna do the same thing. So I forgot to put the weather stripping on in here. Dust protection as well. So one way to do that is to do it like that. Put it backwards, but it doesn't matter. I'm not using this cap anymore. We'll cut that baby off. We're going to work with a smaller diameter wire because I can't get that one to solder at all. So just trying to see where a good splice would be so we don't cut the wire. Hold my finger. So we put the stuff back on. So what I'm doing now is I'm just gonna do this like this. Okay. That's not going anywhere. Maybe I'll put some more on the grounding side, just to be on the safe side. So we'll make sure these wires don't come out from just movement alone. They shouldn't, but well, you never know. Alright, so the black, like I said, I'm not too worried about the green, it's just worried about the power ones. Okay, so we can push this to this side now. Look, 3 and 2. Probably split this down the middle. Alright, so we got our 6 feet here. So now what I'm doing is just taking off this here so I can put in this first, then this, and this. Alright, let's see how it squeezes this cable down, if it does or not. Okay, it's looking good. Yep. Alright, so we got one cable done. Let's see if I can get one more squeeze out of that. Okay. Nice. And then this side, we'll just go ahead and get open right quick so we can test it out on the machine. So I'm just going to cut down back just about this much here. Actually, I got to cut down further than that because the shielding jacket also gets attached to the VFD, so. I'll cut myself. Easier just do it this way. I'm probably going to be cutting a little bit more off than this here, so I'm just going to slide this back like that for now. And we're just going to do a little bit of, just a little tiny test. I do have one of those wire turners, like where you put it around and go like this, but unfortunately it's way too sharp and it gets way too deep, and it actually cuts the copper or into the protective coating of the copper. So like this. So before I even plug this in, I'm going to take my multimeter and just double verify that that I am getting connection on the other half here. So let's try that out. So it looks like 1, 2, then 3, 4. So what I want to do is take my ground. Let's go over to 4. Cool. Take my 1. Should be bottom right, or in this case bottom left. 2. And 3. Even though you're getting continuity in some of these wires, you always want to check all the wires. Cool. So now what we're going to do is hook it up to the VFD in there. So let's go look at the VFD. So I don't have an actual holder to open this up. So let's just use something like that. That pulled big time down. Why did that happen? Hey, we can't find that. Alright, so guess we'll do it with Mr. Baby here. Put the wires through here like this. Looks like it's going to just fall anyway. It almost goes down into here. But for now, I'm just going to pull this jacket out like that. So according to this, it's UVW. So we're going to say 1, 2, 3. I'll most likely have to pull this jacket all the way back. The plastic jacket, I mean, that is. Two. So this is my first time actually going to be trying it with y'all, so. 1, 3. These will get ferrule connectors when I officially install it. And just to be on the safe side, because you should always be safe when it comes to ground. Just go ahead and wrap ground like that for a second. All right. Now here's a moment of truth. Actually, let's go ahead and plug in the cable first. All right, what's going on, y'all? So we got the Cumark controller, VFD controller. Mine is the 580 series. And I just want to show you something right quick. So if you have your spindle over here. So I'm just going to show you this. I don't know if you can see it or not. But it says rated at 400 hertz. And max is 800 hertz at 2400 RPMs, 1200 RPMs. We're running 1200, we're running 2400. So I'm gonna show you what happens when we set this to 400. And then I'm gonna run it. I get instant fault code, fault 02. So looking at the fault code here, it says overcurrent exceeds a maximum permissible level of hardware. Check the motor rated parameters is consistent with the nameplate. Check the acceleration deceleration time is too fast. Well, I already know that the acceleration deceleration time is not fast. It's at actually 10. It's actually a little too long. I only did it because I didn't realize that I had to put it at 800. But other people are having the same issues with not being able to get their parameters to run. So we're gonna reset. We're gonna go back into frequency here, go over 800, save, and then we're gonna back, wait, give me a second. Yeah, motor type. We can't change that either. It's automatically set. I'm just trying to make sure phase, motor phase. Okay. So we're at 3 kilowatts. We're back at the beginning, 380 volts, even though we're pulling 490, close to 600. Amps have to match what's on the motor. This is the nominal speed. So anyways, let's back out. And I don't know how to change that yet, but we're gonna go to the, I don't know how to change the RPMs yet on here, but I'm gonna hit remote. All right, so I got the VFD up and running finally, and I'm about to show you guys the parameters. That way I can help you out with this Cumark 580 series. All right, first off, what we're gonna do is we're gonna hit into menu, and we're gonna hit up parameters. So let's go start from the beginning. I'm gonna try to get through this fairly quick. So these are non-programmable. What that means is I can't edit it. The parameter is read only. So all the way up until I believe about here. Yeah, give me a second. We'll figure it out. Trying to remember what's all read only in here. Anyways, what we're gonna want is this here, step and direction. You're gonna want to click on edit and use this. All right, so you have to make sure that this is either in this program or this program. It doesn't really matter. One is run and two in direction, forward, in direction, and reverse. We'll just keep that as that. The rest stays the same. We'll hit back, start and stop mode, select. Just want to make sure this is ramp. I didn't really mess with any of that. Oops. Analog input, we want to make sure this is 10 volts coming from the Masso. And the min is 0. Yeah, so that's that. Digital input. D1 is delay, and then delay off. That's just, I guess, the signal coming from the from the Masso to the VFD. Analog we're not using. System we're not using. Speed calculation. Yeah, we're not using any of these. Yeah, no. Limits. Max speed you need to do, and then you could do min speed 1000. This is what I had messed up right here. It was 24 and 24. No wonder why it just kept going to 2400 or 24,000 RPM. Sorry. So you got to make sure that this is max, and then the minimum is 1000 for an example. Speed reference, AI1 scaled, AI2 scaled, which we're not using AI2, so that really doesn't matter. Speed ramp, 10 seconds. If you have a brake, I believe this has an internal brake resistor, but if not, get one and it goes down there in between. So I just left it at 10 for now, but you could do 5, doesn't really matter. Same thing with deceleration, but that's it for that. Speed control, don't mess with that. Don't mess with any of these. Yeah, don't mess with any of these. Motor control, just look at it, don't mess with it, just leave it how it is. I have a 4-pole motor. It's 380 volts coming into the VFD. It's supposed to be 400, but I believe this upscales the voltage, a DC to DC or AC to DC converter. So leave that alone, no load, blah, blah, blah. Startup data, this is what you want. 3 kilowatt motor, 380 volts, and 8.6. And all that stays right here. 3 kilowatts, 380 volt, 4-pole, 8.6. Rated is 400 hertz at 12,000 RPMs and max of 800 hertz at 24,000 RPM. So all these are set up. Minimum speed should be 12,000. Just edit that. Edit that. Or nominal speed, not minimum speed, sorry. Save. I guess that's what it's going to leave it at. Motor frequency. These ones you can't change. This you can. One ID request, normal. These ones you can't change either. Drive mode you can't. Phase you can enable. And then that's it. So over here on the Masso side, and sorry for the lights. So for an example, M3, let's say S6000, and run. Alright, so S6, run, should be at 6,000 here. Motor's running, looks great. And we're around 6,014, which is perfect, 1.5 amps, 400 hertz. To stop the spindle, we can either hit the spindle stop or just type in M5 code and hit run. And it just stops it there. All right, so there you have it. The spindle is done, set up. So if you guys enjoyed this, I guess, a learning experience, this curveball, because I definitely took all damn day to figure this stuff out, even though the book is pretty, very well detailed. You got a hardware book and a software book. I can't complain. It's got a lot of great information in there. Next up will be the Z-axis for the machine. So stay tuned for that build. If you guys like this series here, I'm so tired, sorry. Hit that like button, hit that subscribe button, and let's get building.